So, have you ever written a Python script that starts out nice and simple, but then somewhere along the line it just explodes into this tangled mess? Yeah? Well, you're in exactly the right place. Today, we're going to demystify object-oriented programming, or OOPS, and show you how it can turn that chaos into clean, elegant code. We've all been there, haven't we? You start a project, you're feeling good, and then it just grows and grows, and suddenly your code is this giant labyrinth of functions and variables. It's a total nightmare to manage. But don't worry, there is a way better way to build things.
And that solution, that way out, is object-oriented programming. I mean, just look at the difference here. On the one hand, you've got spaghetti code. It's a mess, it's impossible to debug, and you can't reuse anything. But on the other side, a clean, organized, logical structure. This isn't just about being tidy, you know? This is about building software that actually works, that you can build upon, and that's ready to scale up.
To really appreciate why OOPS is such a game changer, let's first take a quick look at the problem it was designed to solve. We're talking about a world of pure functions and logic, which is fine for small stuff, but on bigger projects, well, that logic can spiral into total chaos, and fast.
So what exactly is this OOPS thing? At its heart, it's a completely different way of thinking. Instead of just writing a sequence of commands, you start thinking about your program as a collection of real-world, well, things. Imagine being able to model a car, or a bank account, or an employee, with all their unique details and behaviors, right inside your code.
Yeah, this thinking in objects approach is what makes OOPS feel so natural once you get the hang of it. And to actually build these objects, Python gives us a powerful set of tools which we call the core pillars of the paradigm.
All right, let's dive in. We're about to break down the 6 pillars that make all of this possible. If you can really get your head around these concepts, you'll be writing professional, scalable code in no time.
First up, we have the class. The best way to think of a class is like an architect's blueprint for a house. It's just the plan. It doesn't do anything by itself. It doesn't take up any memory. It just sits there defining what something can be.
And this is the perfect way to put it. A house blueprint isn't a house, right? But it contains all the instructions you need to build one or 100 of them. That's exactly what a class is for our code.
Okay, so if the class is the blueprint, then what's the actual house? Well, that brings us to pillar number 2, the object. The object is where that blueprint comes to life. It's the real, actual thing that gets created in your computer's memory. And from that one single class, you can create a whole neighborhood of unique objects.
This just nails the relationship, doesn't it? The blueprint is the class, the actual house you can live in, that's the object. It's that simple. One blueprint, many houses. One class, many objects.
Okay, next, let's talk about security and safety. This is where our third pillar, encapsulation, comes into play. It's all about bundling an object's data and the functions that can change that data together into one protected little unit. You can think of it like a digital safe for your code.
The ATM analogy is absolutely perfect here. You have a public interface, the screen, the keypad, that lets you do things like withdraw money. But you can't just reach inside the machine and grab the cash, right? Or mess with the bank's internal servers. Encapsulation gives us that same safe, controlled way to interact with our object's data.
So, how does Python do this? Well, it's all based on a really simple naming convention. If a variable name is just normal, like balance, it's public. Anyone can touch it. Add a single underscore in front, and that's like a polite warning sign. Hey, this is protected, you probably shouldn't mess with it. And if you see a double underscore, that's Python basically putting up a wall and saying, this is private, keep out.
All right, pillar number 4, inheritance. This is basically the don't repeat yourself principle turned into a superpower. It lets you create a new class that inherits all the features from another existing class. It's all about reusing code without the nightmare of copying and pasting.
A classic example is a vehicle. Let's say you have a vehicle class, and you define that it has an engine and it has wheels. Now, you can create a new class called car that inherits from vehicle, and boom, instantly your car has an engine and wheels. Then you can add on the stuff that's specific to a car, like doors and a trunk. It's just a beautiful, logical way to build things up.
Now for a really cool one, polymorphism. It's a fancy Greek word that just means many forms, and it's all about flexibility. It means you can have a single interface, like one function name, that can do completely different things depending on the object you give it.
This is such a great way to think about it. The word run means something very different if you're talking about a person, or a computer program, or an engine. It's the same word, but the behavior changes with the context.
Polymorphism gives our code that same kind of smart, contextual flexibility.
And that brings us to our sixth and final pillar, abstraction. This one is all about making complicated things simple for the user. Abstraction hides all the messy, complex inner workings and just gives you a simple set of controls. It focuses on the what, not the how.
You know, we use abstraction every single day of our lives. When you drive a car, you're using an abstracted system. You've got a steering wheel, a brake, an accelerator, a very simple interface. You don't need to be a mechanical engineer and understand internal combustion to get from point A to point B. Abstraction does that same thing for our code, making it so much easier to use.
So, there we have it, our 6 powerful pillars: class, object, encapsulation, inheritance, polymorphism, and abstraction. Now, let's take a step back and see how they all fit together to create truly awesome software.
Okay, let's connect all the dots. It all starts with a class. That's our blueprint. From that blueprint, we create an object, the real thing. Encapsulation puts a protective bubble around that object's data. Inheritance lets us build new objects from old ones, so we don't have to start from scratch. Polymorphism gives our objects the flexibility to act in different ways. And finally, abstraction hides all the crazy complexity from the end user. See how they all work together? It's an incredibly powerful system.
And listen, this isn't just some abstract theory. OPS is the absolute backbone of almost every serious software project out there. We're talking web development with frameworks like Django and Flask, data engineering, machine learning, game development. It is everywhere. And you know why? Because it works. It's how you build robust, maintainable software in the real world.
You know, when you really master these pillars, it does more than just make your code better. It fundamentally changes how you think about building software. It helps you develop what you could call the OOPS mindset.
And this right here is the most important takeaway. OOPS isn't just a collection of rules you memorize. It's a philosophy. It's a way of thinking that encourages you to model the world around you logically and cleanly inside your code. Adopting this mindset is really what separates a good programmer from a great one. So the next time you sit down to start a project, ask yourself, am I just writing a script, or am I building